The topic we're going to take notes on today is graphing square roots and absolute value functions using some transformations. But before we get started, find a little paper that you can jot down some of these terms that you need to know before you get started. Okay, when it says stretch in the y direction, that means you're going to multiply your function times a number, and that's what I'm using the letter A to represent, a number. When it says reflect across the x-axis, that means you multiply your entire function by negative 1, or any negative number. When it says move to the right, that means that you're going to subtract a number from x. So this is how you would write it, f parentheses x minus a number. To move to the left, you're going to do f parentheses x plus a. I know that looks backwards, but that's the way you can remember it. When it says move to the right, use subtraction. Move to the left, use addition. If it says move up, that's the one that makes sense. The whole function plus a number. You put a number where the letter A is. And move down, you're going to put a number where the letter A is. The function minus a number. So move up and move down, it's the way that it seems it should be. Plus moves up, minus moves down. All right, let's get into the notes for square roots. Okay, we're just going to look at square roots today and semicircles later. Notes 21, the function, square root of x, the parent function, we're going to use this parent function to graph all the other functions in this on this note 21. So first thing we're going to do is graph the square root of x. You need to be familiar with how this graph looks and several of the critical points so that you can always graph it and identify it. Okay, the domain starts at 0 and goes to infinity. So x is greater than or equal to 0. Okay, your range also starts at 0 and it's going to go forever to positive infinity. So y is greater than or equal to 0. That's the domain and range of your parent function, square root of x. Number 1, stretch by a factor of 1/2 in the y direction. This means you're going to multiply the function by 1/2. Reflect across the x-axis. This means -1 times the function, and move left 2, x plus 2. Okay, put those three descriptions together to write your function. Remember, our parent function is what we're starting with. Okay, so when we write the equation, we're going to do all of these different things to square root of x. Okay, f of x is equal to -1/2, here's the -1/2, here's the negative, and here's the plus 2. All right, we're going to pick some points for x and plug them into the function and graph them. Okay, when you do these transformations, like I said before, you need to be familiar with the shape of the parent function. The square root of x, you can see from the previous graph, this is the picture of the square root of x. So all your other graphs are going to be similar in the shape. If it's reflected, like this one in number 1, then it's flipped underneath the x-axis, but the shape is still the same. Okay, so I just picked some points that would work. -2, I plugged it in for x. So -2 plus 2 is 0. Square root of 0 is 0. And 0 times -1/2 is 0. So that's where I got 0 for the answer. So the ordered pair, -2, 0. Okay, and then on is how I did that. We'll do one more. X equals 2. Plug that in for x. 2 plus 2 is 4. The square root of 4 is 2. Negative 1/2 times 2 is negative 1. So that's my ordered pair. 2, negative 1. Okay, now to determine the domain and range, I'm going to look at the graph again. The x starts at negative 2 and goes to positive infinity. So x's are going to be greater than or equal to negative 2. Okay, my range is going to start at 0, y equals 0, and it's going to go down. Okay, so y is going to be less than or equal to 0. Example 2, stretch by a factor of 2. That means that we're going to multiply the function times 2. Okay, move it to the right 1, x minus 1, and up 2, the whole function plus 2. Put those three things together. Don't forget, the function we're dealing with is the square root of x. Okay, so I'm going to multiply the square root of x times 2. I'm going to do x minus 1, and then I'm going to put plus 2 outside the function. And this is what the result is going to look like. Before I determine the domain and range, let's plot some points and graph it. Okay, I plugged in x equals 1. So 1 minus 1 is 0. Square root of 0 is 0. Times 2 is 0. So 0 plus 2 gave me 2. Okay, so the ordered pair is 1, 2, and so on. I chose numbers that work out well with square roots. If you want to plug it into the calculator, we can take a look at how that would look. Okay, let's type in, after you type in your equation, then graph it. Okay, you can see that the graph matches, but one way that you could, before you graph it, you could actually go to your table. If you set it up like this, second window, go to ask, and then second graph. Okay, let's type in some values for x. When x is 0, I get an error. That's because 0 won't work in the graph. Okay, if I put in 2 for x, I get 4. So that's one of my ordered pairs, 2 and 4. Okay, if I put in 5 for the x value, I get 6. So 5, 6. This is just one way to find ordered pairs. Okay, if you don't like that, you could have it set up just regular. Okay, go to your table, and you're going to see a lot of different numbers, decimal numbers. Okay, you can see that from 0 all the way to 1, there's errors. When you get to x equals 1, then that's when you start having good values. So the point 1, 2 is an easy point to graph. 0.24. 5, 6, and so on. Okay, this is just one way that you could actually come up with some values. All right, let's look at our graph to determine the domain and range. If you look at the x-axis, we just figured out that the first good value for x is 1, and it goes greater than 1, okay, all the way to infinity. So x is greater than or equal to 1. Okay, the range, the first good value on the range was 2, and then it just keeps continuing to infinity. So y is greater than or equal to 2. All right, we're going to skip over to Notes 23 and look at some absolute value graphs. Okay, the function f of x equals the absolute value of x. This is your parent function. You need to be familiar with this graph. Okay, these are just 4 points that are critical points that you could graph. You could graph others, okay, but make sure you know what the graph looks like, okay, because when we transform it, the other graphs will look similar, okay. The domain of this graph is going to be all real numbers. All x values work. All right, in the range, you can see that there are no negative y values as part of this graph. So y is greater than or equal to 0. All right, shrink by a factor of 1/2 in the y direction. Okay, that means 1/2 times your function. Reflect across the x-axis, that's negative times your function, and move left 2, that's x plus 2. Okay, don't forget the function is the absolute value of x. So when we transform that, the new function, this is your equation, negative 1/2 times the absolute value of x plus 2. All right, let's pick some points and plot that. Like I said, the graph is going to look just like the parent function, except it's going to be stretched and it might be flipped like it says here. Okay, so know what the parent function looks like. All right, the domain, you can look and see that all real numbers will work for x. However, my y values never go above 0. Okay, so y is always less than or equal to 0. All right, number 2, stretch by a factor of 2 in the y direction. That means 2 times your function. Move right 1. Okay, that means x minus 1. And move up 2. That means your function plus 2. When we put all that together, our new equation is 2 times the absolute value of x minus 1 plus 2. All right, to determine the domain and range, let's plot some points and graph it. Okay, my domain is going to be all real numbers. And my y value starts right here at positive 2 and goes up. Okay, so your range is going to be y greater than or equal to 2.